Hello everyone, and welcome to What the Heck Math. Today we're going to continue our talk about limits. So this is part 2 of our limits series. Before we had in part 1 there was we talked about an introduction to limits and the basic idea of what limits are, how to solve relatively simple limits. But the only problem is we only dealt with limits that exist. I kind of mentioned a few times that it might be possible for a limit not to exist, and so that's kind of what we're going to focus on today. So we're gonna look at limits again, but not just ones that exist. So we're going to look at something. We're going to look at one. Oop! I did not mean that to be read. So one-sided and two-sided limits. So with one-sided and two-sided limits, they're relatively simple. The way you calculate them and work with them is similar, but it does help to be able to see what the graph actually look like. Okay, so with one-sided limits, you can either approach the point in your limit from the left or from the right. The limits that we were dealing with before, we were coming from the left most of the time, but if you came from the right, it would have given you the same result. Okay, so for a one-sided limit coming from the right, how you write this is very similar to how you would write a regular limit. You would still have limit, the function, x, an arrow, and your point, but the only difference is you're going to put a little plus sign right here, right above and to the right of the value that you're approaching. This is called a superscript. So you're writing it very similar to how you would write a power of 2 or something like that. Okay, so this is a one-sided limit, and this is coming from the right, and you could also come from the left. So again, it's going to be very similar, but instead of a plus, you're going to put a minus, and this is coming from the left. Okay, and one way that you can help you remember which you should put a plus or minus, depending which way you should come from, is on a number line that's centered at 0. You're going to have negative values to the left and positive values to the right. So to the right, positive, left, negative. Right, positive, left, negative. And it kind of gives you a way that you can help remember which one you should use when you are actually solving and writing limits, but also when given this instruction, you know which one you're supposed to solve. If it's a positive, you know you're supposed to be approaching this point C from the right. Okay, so now let's see how that can actually make a difference. Okay, so there's this one function called the greatest. Okay, I spelled that completely wrong. Let's try that again. The greatest integer function. Hopefully you can read my handwriting. Okay, the greatest integer function. And this is written as, if I'm going to write it in function form, we're going to say f of x equal to int x. Okay. X being the input variable, just like it is here, int being the name of the function. Okay, so this is the greatest integer function, and essentially what it does, it's not something that's used very often, but basically what it does is it takes any x value input, and the output is just the integer part of that number. Okay, so for example, if the input was 3.639, then the output would just be 3. It would just take the integer part and basically cut off everything else. Okay, so that's what the greatest integer function does. Now, how does this look on a graph? Okay, all right, so we're only going to focus on the first quadrant, and so we have 1, 2, 3, 4, 5. Let's label these 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, now the greatest integer function is great for our purposes, especially when we're looking at one-sided limits, because depending on where you're looking, what point you're looking at, the left and right-handed limits are actually different. Okay, so again, looking at the fact with the greatest integer function, how it works, it basically takes any input or any x value input and cuts off all the decimals and only outputs the integer part of that value. Okay, so for x value of, let's say, 0.5, the output would just be 0. For an x value of 0.8, the output would just be 0. Okay, so basically what that means is for all of these x values right here, up until but not including 1, it's just going to be y values of 0. Now, like I said, not including 1, so that means that this is going to be an open point. Okay, so remember, open circles basically means every single value up until but not including that one. Okay. Now, once we get to 1, it's going to jump up here, and we're going to include that, so we're going to color it in. But again, 1.5, 1, 1.8, 1. Okay, so it all starts with 1, so it's going to be nothing but 1 y values, and then when we get to 2, it's going to be open again. And then we just repeat. We jump up, go to the right, open. Jump up, go to the right, open. Jump up, go to the right, open. Okay, and we'll stop there. All right, but this is the greatest integer function. This is basically what it looks like. Okay, now, so let's see how this will work with a one-sided limit. All right, so let's see. Let's do the limit as x approaches. Let's see. Let's do 3. Okay, it's the plus sign. So from the right of our greatest integer function. Okay. All right. So as we approach 3 from the right. Okay. So here's our 3x value. And we're going to be approaching it from the right. Okay, so we're going to be coming from this direction. Okay, so as we're up here, okay, we're not at 3 yet. Okay, this is 4, so we're going to jump down to this level. And we're approaching 3, approaching 3, approaching 3. Okay, so what value are we getting closer and closer to coming from the right? Okay, so hopefully you can see that it is going to be a y value of 3. Okay, so that's what we're getting closer and closer to. All right, because we're only focusing on the values that are extremely close to 3, but greater than 3. Okay, so like the 3.00000000000 repeating 1 values. Okay, the ones that are really close to but greater than 3. So that means the limit as x approaches 3 from the right of int x is 3. Okay. Now, let's look at the other one. The limit as x approaches 3 from the left of int x. Okay. So now we're going to be approaching 3 from this direction. So let's get close to it. So this is pretty close. So we're going to 3 from the left. And we're at 2, 2, 2, 2. We're all at 2, still at 2, still at 2. Okay, so you can see we can't ever get to 3, but it's okay. We don't care. We don't really want to know what happens at 3. That's not what we're looking for. This is a limit. We want to know what's happening as we get closer and closer to 3. Now we're coming from the left, so that means we're going to get really close to 3, but still be less than 3. And our y values are 2. So the answer is 2. So you can see how we have 2 one-sided limits that are approaching the same value, 3, but the solutions are different. Okay, so these two solutions are different, so that means the limit as x approaches 3, this would be the two-sided limit. Okay, when there's nothing here, that means the two-sided limit of int x does not exist because these two values are different. Okay, so that's something that's really important about limits and when we solve limits. Okay, so basically, so a two-sided limit exists if and only if the both the one-sided limits exist. Now at the same point, C, okay? So both the one-sided limits exist and are equal. Okay? So a limit exists, a two-sided limit exists if and only if the one-sided limits that are coming from the right and coming from the left exist and are equal. Okay, so it's really important. Okay, so this is kind of using an analogy. All right, so let's say we have two cars. So here's my great view of a car. Let's go. We got a red car and we got a black car. Okay, so we want to know, like, okay, so we're looking at it from the standpoint of the limit exists. Okay, let's instead of a limit, let's look at an accident. Okay, now these two cars, certain things are required in order for an accident between these two cars to exist. Okay, so for example, if this car drives that way and this car drives that way, there's no way they can get in an accident with each other. Okay, it's impossible. They might get in an accident with some other vehicle or a lamppost or something, but they're not going to get in an accident with each other. Okay, so in order for them to get in an accident with each other, well, first of all, they have to exist. The cars have to exist, right? And they have to meet up at the same place, and then there's going to be an accident. Okay, that's kind of the definition of a car accident, when two cars try and be in the same place at the same time, which is a physical impossibility. So what's going to happen is carnage, a lot of destruction and broken windows and all that. Okay, so in order for these two cars, in order for the accident to exist, the two cars have to both exist and they have to be in the same place. Okay, so it's kind of like a limit. In order for a two-sided limit to exist, the one-sided limits have to exist and have to be in the same place, have to be equal to each other. Okay, so that's just kind of an idea of what two-sided limits are. The next lesson, we're going to do one more lesson about limits, and then we're going to move on to another part of calculus. Thanks for watching. I hope this was helpful for you. If you like it and want to see more videos, please subscribe, share it with your friends, give it a video a thumbs up if you like it, a thumbs down if you don't. Feel free to comment if you want any help in a certain particular area about math. Like I said before, I'll be focusing on calculus for this series of videos, and then once that's finished, I'll move on to a different subject. But again, thanks for watching.